energy is the energy due to an object's position. So for instance, if I stand on a ladder, I have the potential to fall off. So I just gave myself more potential energy. The formula we're going to use is number 2 down here. In fact, let me go ahead and take the little screen up here. And I have no clue where that went. There it is. And that's not working. Okay, so anyway, the formula you're going to use is the potential energy equals mass times gravity times height, or PE equals mgh. The way I remember that is physical education makes guys or girls healthy. That's the clean way to remember it. We won't get into the other way. So number 3 says, give an example of an object with potential energy, and I just simply used a roller coaster at the top of the hill, or an apple hanging from a tree, or Mr. Wright at the top of a ladder. So any of those are good things for potential energy. Something that gives you height. Now, number 4, the definition for kinetic energy is going to be the energy that is due to an object's motion. So the faster you're going and the more mass you have, the more kinetic energy you're going to have. It's going to equal 0.5 times the mass times the velocity squared. So KE equals 1/2 mv squared. I just remember the weird way which kids eat 1/2 of most of their vegetables in a square meal. Kids eat is KE, and most of their vegetables is MV in a square meal. Okay, anyway, if I want to get an example of an object with kinetic energy, it's going to be the roller coaster moving to the bottom of a hill. Okay, that's the roller coaster moving to the bottom of the hill. That would be something. Now, the unit for energy is named after a guy whose last name was Joule, as in family, or what a lady places on her ring. And often just abbreviate that with a J as well. Number 8, what's the potential energy of a 1,500 kilogram roller coaster at the top of a 55-meter hill? Show the formula substitution, answer in units. So the first thing I'm going to write down is the PE equals mgh. So you got this formula here. Once again, the mass is in kilograms, so I'll put in the 1,500 kilograms for mass. Gravity is always 9.8. The height was 55 meters, and when you put all that together, you get 108,500, and the units for energy is joules. Now, there's a law that's going to call the law of conservation of energy, and that just says that energy cannot be created or destroyed. It's always transferred from one form of energy to the other. And that means that all potential energy is somehow or another converted into kinetic energy or heat. And so if I wanted to know on number 10, how much kinetic energy of the roller coaster in number 8 would have at the bottom of the hill, it would still have 808,500 joules, because energy cannot be created or destroyed, only transferred. So all the potential energy at the top becomes kinetic energy at the bottom. And lastly, but not leastly, for this short little video, if I want to know the kinetic energy of a 1,500 kilogram roller coaster traveling at 65 meters per second, we're going to use that K equals 1/2 mv squared formula. And I'm going to bring down my 1/2, plug in my kilograms of 1,500. They said the roller coaster was going 65 meters per second squared. And so you simply, or meters per second, and you square that. And that gives you 3,168,750. And once again, all energy is measured in joules. So that's going to get you a head start for the next chapter. We're going to go out and do a little lab where you're going to run up and down the stairs and walk up and down the stairs and figure out how much work you did, how much power you used, and then finally, how much, what the heck's that one? How many calories you burned. Okay? So hope you have a great day. Love you. Bye.